Right, Assalamualaikum and a very good day. So today we are going to have a short video just to explain to you what the next term of slope deflection equation means. So if you look at this closely, alright, this is the equation. Just use my red pen. Okay, so if you look at this quite closely, the moment deflection equation will have a function of theta, function of fixed end moment, which is the load, and also have a function of delta over L. And this is basically only happens for beams when you have settlement. Alright, so now let's see one application of this. Alright, previous examples, no settlement at all. So to this example, we are going to see what happens when you have settlement. Alright, so the question says that support B settles by 20 mm. So this is support B and it settles by 20 mm. So let's redraw the diagram. So say I'm redrawing nicely. Okay, this is your support. Okay, and then what happens is if you look closely, then support B settles down. Sorry. By 0.02 meters. Alright, so what happened is that, okay, exaggerated, A is going to look something like this. Okay, this is point A, and this is point B, and this is point C. And for point D, only because of settlement, CD, there's no movement in support CD at all. Okay, if you look closely, okay, there's no movement in support CD, only support B settles. Alright, so if you want to determine how much is delta over L, okay, delta over L can be rewritten as a symbol of this rotation lah, basically. Okay, so for AB, if this is B, then you just look at AB only. What happened is that you are going to have a clockwise rotation at AB. Okay? Clockwise means you measure it from the horizontal line, original, to the new slope, which is clockwise. Right? Similar, the same span. So if I take, let's take the yellow line. Okay. So if you only look here, okay, at this span, you will see that this beam BA, okay, this point also going to have a clockwise rotation. Original is horizontal, the new one is slanting like this. So the slope is also clockwise, and the value must be the same, lambda. So it doesn't matter whether it's lambda AB or lambda BA. Okay, you are going to have the same value, and the direction is also the same, clockwise. Alright, so then if you want to determine what's delta over L, okay, so basically, okay, it's going to be, if it's clockwise, then you put a positive value. So the rotation would be, okay, delta, which is here 0.02 divided by length. So it's basically the tangent of this, the rotation, the amount of rotation, divided by 8 meters. Alright, so you are going to have that. Okay, so it doesn't matter whether it's AB or BA, you are going to get the same value. So it's basically psi AB. Okay, so this is AB, this is also AB. Okay, because you are always going to get the same value. If you look at the other span, so let's use another color, this is the other span. Okay, if you look at the other span, you are going to see that okay, for the other span, okay, this is the original line, this is the new slope. So the rotation is counterclockwise. Okay, similarly, if you look about point B, okay, this is the original horizontal line. Okay, the new line is here, so it's going to be counterclockwise. Okay, original to the new slope. Okay, this is counterclockwise. Okay, and the value is the same. So then, okay, the rotation for BC, okay, it will be the same for both. This is BC, this is also going to be BC. So it's going to be equal to delta B divided by the length. Sorry, this is also delta B. Delta B divided by the length, okay, is the tangent and opposite divided by adjacent. So, but then, as you see, the rotation is counterclockwise, so it's negative 0.02 divided by 8. So the positive and the negative will depend on whether the rotation is clockwise or counterclockwise. If it's clockwise, it's going to be positive. If it's counterclockwise, it's going to be negative. Alright, so then if you have a slope deflection equation, what you basically do is just input the values here. Alright, so if you see the degree of freedom for this example, okay, theta A is 0. Theta A, okay, sorry, you only have degree of, your degree of freedom is only theta B and theta C, and basically, okay, nothing else. So if you use this slope deflection equation, then for AB, okay, the one where you have slope is AB and BC. Okay, so if you look here, these two will have a value of theta. Right, for AB, okay, theta A is 0, and then this one, delta over L, is going to be positive. Okay, so what you're going to put here is delta is going to be 0.02 positive, and L is equals to 8. But then retain whatever sign that you have here. If it's negative, and because your rotation is positive, so it's minus lah. Alright, so you are going to get the same value for BA. Okay, the only difference is your rotation is 0, slope is 0, but this one is 0.02 over 8. Okay, for BC here, if you look here, BC, you are going to have a negative value, and so you just input a negative value of 0.02 divided by 8. So it will become basically a positive value lah. Alright, same goes there. Alright, negative 0.2 and then 8. Alright, and then CD here and BC, you don't have any rotation due to settlement, so this is basically 0, this is basically 0. Right? And don't forget, all of your fixed end moment are 0 because you don't have any loop. Okay, and then you can try and solve this problem. Okay, basically just using equilibrium. You will get theta B equals to 0.0005, theta C negative 0.002, and then just your moments negative 98. Okay, and then you can go on solving the others. Alright, I hope it is clear. Okay, thank you very much.